Hi, welcome to the talk about asserting reliable convergence for configuration management scripts in order to configure distributed applications in new machines, offered by the Stanford Scholar Initiative. Configuration management tools being used for automatic deployment and convergence of elastically scalable distributed software applications, namely Puppet, Chef, Ansible, etc., have problems with the following. 1. Achieving desired system specifications. 2. Despite being automatic, they still involve a lot of manual work. 3. They are unable to handle faults caused due to temporary conditions. Rising elastically scalable distributed applications need to be backed up with robust and repeatable software deployment processes to minimize the problems presented previously and to ensure automatic provisioning of IT infrastructures. This calls for a systematic testing support for the developers. Here are a few reasons due to which this problem is hard to solve. There are too many possible execution orders of configurations. It's hard to attain the desired configuration specifications in different environments under changing conditions. Also, it's quite sophisticated to define a black box approach for configuration management tools. This paper is about applying a model-based testing approach to assert whether a configuration management script reliably converges the system to the desired state by the application of automatic failure-proof actions. Test cases are generated and are tested so that all issues regarding idempotence and convergence are detected. This paper contributes a formal framework based on a conceptual model that was used for testing configuration scripts for convergence issues, and certain results were generated. So let's see what the authors did. The authors defined a conceptual model which was based on defining a property called preservation, which formed the core of their test approach. They described a data structure called minimal state transition graph, which was utilized to generate test cases. Finally, a test approach was defined. Before moving further, let's see how preservation is defined. A resource B is said to preserve another resource A if resource A is still satisfied after applying B. It is a concept that was used to enable pairwise testing of resources for idempotence and convergence in a feasible amount of time. It was concluded that preservation, when satisfied pairwise among resources, implies convergence for the entire configuration. Now let's discuss what are minimal state transition graphs. Here, have a look at a minimal state transition graph. It has the fewest relevant state partitions and transitions. Thus, it drastically limits the amount of generated test cases, making the test approach feasible. Now we will talk about their test approach. Each resource action for a configuration specification was tested for the following properties. 1. Idempotence. 2. Preservation of states attained by previous resource actions. 3. Preservation of states attained by any independent resource action. By testing for certain specific properties, the set of action sequences with desirable test cases were extracted from a set in which they were mixed with the undesirable test cases. Let's see the algorithm used to generate test cases.
First, a minimal STG is generated, then a set of path P is generated using the path selection strategies like path coverage, edge coverage, and weak edge coverage. Finally, test cases are generated and returned from the set of selected paths. The real-world application of this contribution is an open-source prototype called Asserting, which is based on their approach. Though it primarily focuses on testing Puppet, other configuration management tools can be merged with it because of its modular nature and because of the conceptual similarities in the existing configuration management tools. This is how the Asserting framework is implemented. The architecture for Asserting comprises of following major components: Test Manager, Database holding configuration specifications, Test Environment Manager, Test Agent, Transparent HTTP proxy. Reliability tracking system changes that are affected by configuration scripts is a core requirement of their approach. So a method was devised to track system changes in persistent and transient system states. A set of large-scale experiments were conducted to evaluate the proposed solution. 101 test modules were selected based on downloads and resource utilization and were tested on 2 GB RAM and 40 GB hard disk machine. The aggregated test statistics are as shown. These reveal that the amount of valid execution orders depends on the number of resources and on the dependency relation. The more dependency among resources, the less valid execution orders there are. Now let's see what did they find. The test results reveal that the proposed framework was able to successfully detect all known issues and 5 unknown issues regarding idempotence and convergence in the set of test scripts. This slide shows the potential causes and issues for non-idempotence and non-convergence of the configuration scripts, as these lead to the violation of resource preservation, which is a property that implies idempotence and convergence. Here are some important points and future possibilities that were proposed by the authors. With this, we come to an end of this presentation. To view more talks, please visit scholar.stanford.edu. Thank you.